I'd like to start my presentation, show a short history where Russian ekranoplans stemmed from. So I wanted to show what was the basis on which the first Russian ekranoplans were built. From viewpoint of special requirements on stability for ekranoplans, which make imprint upon aerodynamic configuration of the craft. First of all, I'd like to show you some video with some comments. The film starts with ekranoplan Orleanak. I'd like to remind the dimensions of the craft. Weight about 140 tons.
Корабль «Экраноплан» при своем движении на крейсерском режиме опирается о воду через динамическую подушку, создаваемую под крылом встречным потоком воздуха. Экранный эффект, влияние близости поверхности, увеличивает несущие свойства крыла. Он имеет высокое аэродинамическое качество и способен к длительному устойчивому полету.
Now the flaps are going up, and the path is mostly cruising plan. Here you have relatively high ground clearance, about 3-4 meters, and then it goes down to cruising height. That's the end of the landing. Now you can see it's amphibious and it can go ashore.
Экраноплан амфибиен, способен принимать и высаживать на отлогом побережье.
Это тот же Алексеевский эффект, что и на малопогруженных подводных крыльях. В обратном зеркально-обернутом варианте и иной воздушной среде. Экранопланы, как и СПК на малопогруженных крыльях, обладают естественной природой данной устойчивостью по высоте и крену, что обеспечивает их высокую надежность в эксплуатации.
This is a complete self-propelled model of an analog of Caspian sea monster, KM. First it was tested in Gorkovsky Sea, and then the full-size ship was tested in Caspian Sea. This is how amphibious capacity was tested in winter conditions. That's the first model with power augmentation, blowing of the air under the wing.
Облик экранопланов первого поколения в основном определился по результатам испытаний модели SM-4.
Eventually, configuration was determined by way of trials of these preceding self-propelled models. These are amphibious regions in summer. That's going on the beach, climbing the beach. And you see quite miraculous capacity. You have different, still overcome.
Модель явилась аналогом для корабля-макета КМ экспериментального экраноплана натурной лаборатории.
And finally, this is Caspian sea monster KM. Ten engine. Overall take-off weight about 550 tons.
Тяжелая, и ответственная эта задача – сделать нормой полет над неспокойной поверхностью моря на высотах, исчисляемых метрами, а иногда и дециметрами. Для этого надо не только понять, но и почувствовать летающий корабль, познать его привычки и капризы, уметь управлять этими капризами. Корабль «Макет» был поднят с воды при массе около 500 тонн, и на нем зафиксирована скорость более 500 км в час.
That's probably the end of the historical part of the video. You can switch off the light. That's evolution of Volga 2 into a up-to-date commercial craft, Aquaglide.
Water is a part of our life, a means of having fun and going places. Imagine a craft that combines convenience of a boat, speed of a helicopter, with functions of a hovercraft. Such crafts are becoming a reality. They are called Aquaglide. Unique features of the craft, such as high speed combined with safety, ability to operate on water and land in summer or snow and ice in winter, have been tested and confirmed by prototypes. Commercial manufacture was started in early '98. The design uses modern materials, production technologies, and equipment. Glass fiber composite panels are main structural elements. Rules and procedures of certification were worked out and officially issued. Each boat is granted with a certificate of conformance by the Russian Maritime Register of Shipping, allowing commercial operation. Comfortable interior and simple controls make driving Aquaglide a pleasant experience. Its elegant appearance, fuel efficiency despite the high speed, ability to surface on its own, make the boat attractive to boaters and their passengers. A presentation to the city officials was made after trial operation of the boat in Norfolk, Virginia, the United States. Insurance policy for commercial operation was obtained from one of American insurance companies. Trial commercial operation followed shortly from various locations in Freeport, the Bahamas. The idea of boarding the boat on land turns out to be very attractive to the passengers. the sensation of flight over water is fascinating, especially when you're delivered back to land. The innovative concept and impressive performance of the craft attracted attention of broadcasting companies. First channel of the Italian TV, BBC, and Channel 4, in association with Discovery Channel, made extensive reports on the craft. Power-augmented aerodynamic layout makes the craft amphibious. It can move over practically any level or slightly inclined surface. Amphibious operation becomes a decisive factor when water is shallow or sandbanks are bared by the low tide. Aquaglide is transported in a 40-foot high-cube sea container to its location. Practical experience of operating the boats in different regions of the world resulted in design and construction of a modified craft with improved user features covered with a new patent. Production technology and commercial operation methods have been perfected, allowing to transfer the production to areas of future operation. Designers of the company have been working on ekranoplans for over 40 years. Aquaglide ekranoplan proved the principles of ground effect operation, safety, and commercial feasibility. It has been exhibited at international boat shows. Center of Ekranoplan Technologies Elsin is not oriented towards large-scale production of ekranoplans. We offer R&D, prototyping, and manufacture of pilot crafts with the aim of transferring commercial production to interested parties.
Now you've seen that these vehicles can fly in ground effect. Now I'll try to make more clear what is needed for them to be stable. Frankly speaking, there are many aspects in all kinds of questions of controllability, steerability, and stability, which certainly impact the configuration of the vehicle. But one of the principles is the requirement to secure longitudinal stability of the cruising flight in ground effect. Once one of my friends from America asked me, why do large Russian ekranoplans have such large tail units, horizontal stabilizers? And I'd like to respond now, because I think it's been a phase of a natural evolution of the craft when trying to solve matters of longitudinal stability. It's common knowledge that analysis of any motion is started with equations of motion. These are perturbed motion equations for longitudinal motion. There's longitudinal axis, vertical axis, and also equation for moments. And based on our experience, we're usually writing down these equations in Earth-related system of coordinates. And we also use special expansion of aerodynamic coefficients in the same Earth coordinate system, which was proposed by Professor Treshkov from Marine State Technical University of St. Petersburg. If certain simplifications and derivations are made, this results in a basic system of linear differential equations of motion, which looks like that. it doesn't matter maybe, but it is upside down. But it's only to say that the analysis of dynamics of motion is a very complicated thing, at least not simple. If we try to... Now we go back before we speak about simplifications of these equations. And let's now start with y and mz equations. Singling out the so-called position part, which concerns directly kinematic parameters such as ground clearance and pitch angle. And then we'll try to analyze the ratios of the increment of height to the increment of speed, equating naturally in both equations to 0, which is equivalent to the condition of balanced flight. That is, both moment and the force are 0. As a result, we derive two very simple but significant expressions which characterize static stability of ekranoplan when flying in grounded fat. The first is a number of meters of height, which is augmented with respect to the unperturbed initial motion when the speed increments or augments 1 meter a second. And now the second relationship prompts how does the first motion take place. Does the pitch angle change or not? And if does, what is the sign of the change of the pitch angle? It is more or less clear that the less is the first ingredient, the more ekranoplan is bound to the ground. So that the larger perturbations are needed to considerably change the ground clearance. In Russia we call it binding to the ground. From viewpoint of experience of operation, we have stated that any variation of height in the process of changing the speed, it is required that it is better that it is not accompanied by variation of pitch angle. So the height should change without variation of pitch. So it is desirable that the second ratio be as small as possible, closer to 0 as possible. In the structure of the first expression, there is one factor which is similar in both formula. This is whatever has been given by a designer who developed this vehicle to the vehicle. That's the chord, that's the speed of motion, etc. And also, it also reflects geometry of the wing, which has a certain derivative in height and in pitch. These are characteristics, the formal characteristics of the wing. And the fraction which follows at the second factor in the formula is what this basic wing geometry is accompanied by when we go into the vehicle configuration. So it, for example, reflects position and parameters of horizontal stabilization. Let's consider the first expression. In the denominator, we have reserve stability in angle of pitch, or in angle of incidence, if you will. This magnitude, when designing the airplane, is usually made positive. That means that the center in angle of incidence should be behind the center of gravity for the airplane. And the cunning thing or peculiarity of a chronoplan is in denominator. Because the notion of aerodynamic focus or center has been developed in aviation, and of course the lift of the airplane depends, as it knows, on the angle of attack mostly, angle of incidence. That's why in aviation, besides the notion of the pressure point, a center of pressure, there's been introduced the notion of center in angle of attack. Because this was the only kinematic parameter on which the lift is dependent. In the case of a chronoplan, we have a peculiarity. The lift depends not only on the angle of incidence, but also on height. That's why, by analogy with aerodynamic focus in angle of attack, which was introduced in aviation, we introduce focus or center in height, in ground clearance. It appears that for longitudinal stability of a chronoplan, one has to design this vehicle in such a way that the center in height is ahead, is upstream of the center in pitch. But it's interesting to deduce from this formula that if the center in height coincides with center of gravity, then we see that this coefficient is equal to unity. And then we see that then the final or eventual properties of the vehicle depend largely on the design of the wing. And the rest of the configuration doesn't hinder this property of the wing. However, if we put center of gravity ahead of the center in height, we can see from the structure of this expression that this coefficient would become less than unity. That means that by improper, in this case, design of configuration, we weaken those properties that were based on the properties of the wing. It is obvious that when the center in height coincides with center of gravity, then the second expression is identical to 0. Then in this case, when the speed is varying, then there is a parallel advancement of a chronoplan. There is change of height, but there is no change in pitch. So just controlled by the speed. So there ensues one of the principal rules which has already been cited. And now, as we saw, beside the fact that the center in height should be ahead of the center in pitch, this center in height should be located not far, close to the center of gravity. It is obvious that in practice it is realized in the following way. or it can be done through proper design of the glider and arrangement, and in such a way that the center of gravity is placed into the center of height. Or if people who work on design are strong in aerodynamics, then they start to work on the center in height, in order to bring the center in height closer to the given center of gravity. And it's evident that there is a convergence of both points. From one side, the center of gravity moves toward the center in height. On the other side, aerodynamically, they try to put the center in height closer to the center of gravity. This is what concerns static considerations of stability. And this reflects, this corresponds to a smooth variation. It's quite natural that in practice it has a dynamic character, because there are also organs of control surfaces. And the analysis that has been put into the paper and lecture has shown that in dynamics, after the transition process has taken place, some parameters that were in existence in static considerations also have certain sense in dynamic analysis. It is known from dynamics of flight one sees dynamics more clearly when one reduces the differential equation to a second order. So if we treat dynamics of the flight from this viewpoint, so we see that the motion that is can be considered as principal for ekranoplan when in cruising flight in ground effect which is connected with displacements or motions of ekranoplan with respect to height and pitch, can be approximately represented as an oscillatory link of the second order, with the basic frequency which is shown by the formula, which is also proportional to derivative of lift coefficient with respect to ground clearance, and then multiplied by the difference of the centers, distance between the centers, and divided by reserve of stability in what they call overloading. The better this characteristics is, and that's the best when the center in height coincides with the center in gravity. Then this basic frequency in height corresponds to a basic frequency of parallel motion in height. And as far as decay is concerned, of oscillatory or transitional motion, this doesn't depend on those parameters mentioned, because this other property changes according with this formula, where we do not see influence of the difference in position of the centers. And the whole decay is now determined through two ingredients. One through damping of angular motions, which is usually done through automation. But the second term reflects also the difference, but that's not the difference between center in height and pitch, That's the difference between center in pitch and center in vertical velocity. You see H dot. Therefore, the static characteristics of ekranoplan, which are related to the height, do not have influence upon dynamics in this sense. Therefrom, we can deduce the similar rule. So that both for statics and for dynamic stability, it is recommended to have the center in height coincide with the center of gravity. That's a small essay sur stabilité.
There is.
Он знал это правило. Going back to large ekranoplans designed by Alekseev, who didn't know this formula, it was very curious to find out that he would design his vehicles using this rule already, this concept of centers. And strangely, as it seems to us now, going back again to what he did, he had a good intuition as an engineer. But because Alekseev in those times didn't know how to control the center in height, so he had his center of gravity somewhere in the middle of the chord. And of course, for such position of the center of gravity, you have by necessity large area and volumes of the tail unit.
There is some time for a few questions, if any. Is there some questions?
Oui. Ça marche? Bernard Mazur. It is not a question, it is just to know if it is very interesting, this presentation will be in the proceedings, and will it be in English or in Russian language? In the proceedings, the same things? Thank you.
Are there other questions? Yes.
Stefan, I have a question about the center of 8 and the center of H dot, which you call. The first thing is, how did you find that the center of H dot wasn't so important, and how did you measure the importance of the H dot on lift? Because well, you cannot measure it in a wind tunnel. How did you find it?
First, I'd like to again explain the physical sense of this center in height, in vertical speed, sorry. For small Strual numbers, that is relative frequency. I'm not telling my own achievements, that's more or less been given in the papers by Professor Trishkov. The vortex sheet that is behind the wing, especially that of small aspect ratio, which is used for ekranoplans, has a sort of a sine form with the frequency of oscillations of the wing. And there with both the position and intensity of this vortex structure are changing. Okay. So both the kinematic geometry and intensity of vortex structures are varying with this and changing position with respect to tail unit. In aviation, there is a so-called delay or time lag of the downwash with respect to angle of incidence. That's the same kind of time lag of the downwash, but also due to variation of height, as contrasting to aviation. But there are two ingredients of the lag of the lag in the downwash of the flow. There is changing the radius vector of a concrete point of the vortex sheet with respect to stabilizer. And then, of course, the intensity of the vortex is changing. It is obvious then if our stabilizer occupies momentarily next position, then there is no downwash lag. So again, the change, the velocity of the rate of change of height. This is what influences the downwash and the lag of downwash on horizontal stabilizer, which is, as shown, one of the properties influencing dynamic stability in longitudinal flight. This can be estimated quite fairly. This can be, you can even use elementary horseshoe expansions around some steady state. But we also made some time ago, many years ago, an experimental attempt. And this was a joint effort with Marine Technical University, and we manufactured an installation, designed and manufactured a special installation which enabled to have some prescribed motions of the vehicle in aerodynamic wind tunnel. And then this would be calculated using a rather complicated mathematical model to find the influence of the rate of the height. And we found out that this component not only exists, but really influences the parameters. But it is very important to have exact estimation of this property, because one requires rather large accuracy to do it. Of course, from viewpoint of design and not a scientist, it is better to control these things by automation, automatic control systems. Then we would switch on some kind of Japanese automation device, automatic control system element. Okay, I think this was shown.
Thank you.
And eventually we have very nice degree of decay.
Thank you. I think there is another question.
Thank you, Jean-Gaël from SSG-AERO. I would like to know if what kind of effect does the type of engine and the way of driving the engine has on the stability.
Frankly speaking, with those reserves of stability with respect to pitch angle, that was employed in our large seagoing ekranoplans, there was no noticeable influence of the regime of operation of the engine as far as parameters of stability, for example, and the like on parameters of steerability. So with those reserves, there was almost no impact. Of course, positioning of the engines, the positioning was of the engines was chosen in such a way that this influence be the smallest possible.
Okay, no more question. Ah, yes, maybe the last one.
Maybe it was something I didn't get, but this frequency. About what frequency ranges are these? This frequency in height.
Would you please repeat?
Yeah, I'm just curious about this frequency of in the stability study. What kind of frequencies do you expect? I mean, the range of hertz.
That's about at most half or 1 hertz.
Okay, so it's
of course, the chronoplan has many faces, many facets. If it flies at limiting very close distance, then the derivative in height is so large, then the frequencies can be very large, and the amplitude small. And suppose the height augmented 3 meters, and then the frequency becomes smaller because the derivative goes down. Derivative in height goes down.
Okay, so it's a fairly slow system, so it's no
Это довольно медленная система. These frequencies, in any case, are 1 order of magnitude lower than those frequencies, которые где? Which are analogs of short-period oscillations of the airplane. That is what we call establishment of overloading, of certain overloading level. So in fact, one is able to distinguish these frequencies, and this gives additional possibilities for design and control.